I, Harshad Gautam, on behalf of SAE India JUET, welcomes you all. It is my honor to welcome Mr. Aditya Verma, who is currently former design engineer at IRUS, and he's one of the finest of our alumni, and he has served as former steering head in Arden Clan Motorsports and also have captained cricket team at our university. Today he will be briefing us about aerospace industry. Now I would like to hand over the presentation to Aditya sir.
Thank you, Arshit, for such kind words. So let me introduce myself once again. My name is Aditya Verma. I am a pass out of JP University of Engineering Technology of batch of 2019 from mechanical engineering. So today I'll be talking upon on the topic of how to get a job or how to be ready for an aerospace industry. So industry is recently getting a lot of you can say light so on how on the basis of drones, UAVs, and other stuff. So I shall start now. Just a second. So can you see my screen, everyone? Can you please write something on the chat box? Can you see my screen? Yes or no? Can you see it now? Okay, it seems like now you can see. So now I will start my presentation. So today I'll be talking about how to enter the aerospace industry. So today we'll talk about some drones, types of drones that are available in the market. There are various type of drones that you will see in the market right now. Next, opportunities in the aerospace industry. So what jobs or what opportunities you can get in the aerospace industry and how to get them. And we'll also talk how to get them, what projects or skill sets you should have to get that opportunity. So just a quick question before I start my presentation, that what is the difference between aerospace and aviation industry? Can anyone tell? Feel free to answer the question, no issues. Anyone? You are free to open your mic and answer the question.
Hello.
Hello, yes.
Yes, actually, the difference between these two are like aviation industry is related to some manufacturing of commercial vehicles, and these aerospace industries are related to the manufacturing of space shuttles and all, which can be driven on space and on Earth also.
Uh, uh, you are very close, but not that accurate. You are very close to the actual definition, but not accurate. So, anyone else would want to try? So, no one. So, I'll just tell. So, basically, aerospace industry is composed of, as I said, is composed of all the aircrafts. It also comes of commercial and offers space aircrafts, also defense, military, and that's all. But aviation industry only gets the focus on how to commercialize on only commercial flights. Like for Boeing, they make that Airbus 737. and Boeing 737 and Airbus A320. These flights are in comes in the aviation industry, where you see the shuttles, space shuttles, drones, jets. These all comes in the aerospace industry. So this is the main difference that is there. So now I'll talk about the drones. See, and in the drone industry, drones are differentiated in many ways on the basis of on the frame, on the number of rotors, on the basis of power. But basically, what we do is the main thing. We differentiate them on their airframe. So the first one is fixed air wings air drones. You have all seen these drones in recent times. Recently, ISRO also, sorry, my bad. DRDO has tested a drone named Rustam. Have you heard about it? Anyone?
Yes, sir.
Yeah. So what is the advantage of these drones? See, these drones have high endurance and range. So basically, if you use these drones, they will have a lot of high endurance. That means they will have a high flight time, about 3 hours, 4 hours, as you have required, and also have high range. That means if it take off at some point, it will go very far and come back. That's called range. Secondly, they have high payload. So basically, drones are made to carry some you can say equipment or some parcels, anything, or for surveillance. So basically, these drones are used for transporting equipments, medical aids, and etc. So these drones have very high payload capacity. You can put a high, very high weight of payload, and the most advantageous thing is that they are naturally stable. That means the forces that are applied on these drones are stable. You don't have to do a lot of you can say calculations or something to make this drone stable. Okay, so the next is VTOL drone. I think you have seen all these type of drones everywhere in marriages or recently in your locality for the thermal checks, I think. So these are VTOL. The full form of VTOL is vertical takeoff and landing. So these drones are hovering capability and are very simple to make. But there's one disadvantage of these drones. These drones don't have high endurance, high range, and they can't carry a lot of you can say payload. The weight, the payload capacity is very low. So that is why these drones are generally used for surveillances, surveilling a small area. And right now they are using these drones for you can say for thermal checks, and also they use these drones for pesticides, pesticide the fields. Okay, so the last type of drones that we classify with the type of frame airframe is called as translation drones. These drones are combination of both the fixed wings and the VTOL. So they have advantages of both the types of drones. They both it can hover at a certain place, it can go a long distance, and so on. But these it has a very complex mechanisms. As it goes high, you have to switch from hovering to flying mode. So it is a very you can say a tough task to do for coding purposes, for mechanical purposes, and so on. So, but it has all the advantages that both the VTOL and the fixed wing drones have. Okay, so this is about the drones. Now I'll just go to the opportunities that an that the aerospace industries offers. So anyone know what opportunities are there in the aerospace industry other than what I'll tell, or you have some any idea what the industry requires? Anyone?
I think they mostly try to recruit engineers who are specialized in CFD and all.
Yeah, CFD is one. Right now, I can see the chat box like Rajat Bisht is typing about aerodynamics and fluid physics. Yeah, this is about this comes in the CFD part. So a CFD engineer does all these jobs. Anyone else would like to try? No, so should I continue the presentation right now? So basically, what aerospace industry requires the most important are simulation engineers. So these engineers basically do what to do. They simulate flow patterns, or they simulate FEA analysis on wings and the components. So it is a very you can say a very interesting job to add. This is what I do in my ex company. So basically, what we do is we simulate CFD and FE analysis on various components of our aircraft. So, like right now, I was working on a project that I have designed a small wing for an very handy aircraft or fixed wing aircraft, which was belly landing capable and has a range of 30 kilometers. So, I did a CFD analysis to find the lift and drag coefficients over the wing of my speeds, what I have calculated with my calculations, the cruise speed, the stall speed, and others. So this is one of the most important jobs that you can get in the aerospace industry is a simulation engineer. So these is what most common simulation is done in the industry. Most important. The second opportunity that you can get is of design engineering. So for this type of job, you should have very good 3D and 2D design skills on using the softwares. So basically, what we do in the industry, we use Creo, and we also use SolidWorks if possible, because we don't use SolidWorks that much. We mostly use Creo. So this is what we do. As you can see, I have put a sample of how I've designed a wing, and and also design engineers also do the calculations and other stuff. Suppose I have the requirements given by my customer that I have to make an aircraft which is if it has a very which is hand launch capable, or has a runway that the customer has a runway of 50 meters or 60 meters, and it has to fly through that only and land through that only. So according to these the requirements that are given to us, we design an aircraft and make a CAD model for it and a prototype for that. Okay. And one of the most common jobs we don't see right now is a UAV test pilots. So these are also hired. We mechanical engineers are also hired for this role only, for testing of UAVs. So basically, what is the main job of a UAV test pilot? The job is to conduct flight test and give feedbacks about the aircraft. It is not tilting somewhere, or it has not getting that proper, you can say it is getting too turbulent to fly it, or some control issues. So basically, this is what a test pilot does. It gives us a feedback about the prototype, how it is flying, and other things, because sometimes it happens then when the our drone is flying and sometimes cuts connection with the remote. So these types of you can say problems occur a lot of time in our testing. So these feedbacks are given us by a test pilot. Okay. So the next thing I want to just get to how to get ready for this type of industry. So what software skills do you need? Okay. So the first is that you need to have a good knowledge of CAE softwares, computer aided engineering softwares. So basically, we majorly use these two softwares that are written on the screen, that are Star CM Plus, which is made by Siemens, and ANSYS Workbench. Okay. And the second one is Xfoil. Xfoil is a very handy tool to to calculate the you can say numerical values of a wing. Okay. So it is also very handy, because if you only want numerical values, you don't want to see the pressure plots and other velocity plots, you can use Xfoil to just get the numerical values of lift and drag and moment of coefficient of moments at the tip of the wings and other stuff. Okay. Now comes the third one, is that is the CAD softwares. Okay. So CAD softwares are mainly for designing purposes. Okay, so we use SolidWorks, Creo, and AutoCAD. AutoCAD is basically when we use when we need to make 2D drawings and other stuffs. Okay, and the last one is the ROS, that is called the robotics operating system. So this is used to code the aircraft about the patterns that we make, because if we need to make the UI of the aircraft, how it displays, okay, and other operations that we need to code on it. Okay, so that is why ROS used, robotics operating system. Okay, now we come to the part about projects. Okay, so basically, I didn't have these type of projects in my engineering, but luckily I got this job because of my software skills of ANSYS and SolidWorks. So I'll let you know what the project you should get in your curriculum right now, and while you are in your university, to get the other. So basically, there are many research papers online that you can refer through also. So the most common is that projects are done, that is CFD, analysis of components. There are various CFD component paper on CFD for analysis of wings. Okay, there are many papers on that. They do there are a lot of patterns to do so, and there are a lot of things. They are like there's a recent research paper that I read was about using of bleed air to clear the runway. So I think you have all known the current. There was a recent accident happened in the south where a runway overran the runway and crashed. Have you heard about that? Anyone?
Yes, sir. Tabletop runway.
Hello? Yes, can you speak again?
Yes, sir. Tabletop runway.
Yeah. So what happened that way? The runway was too wet, too wet. So the plane overran it. So there was a project on which they used the bleed air. See, we all know that most of you must know, because I think about above third year, students above third year knows that air is used as a refrigerant in an aircraft. Okay, I think third year students of a third year might know it. They have read it in their RAC, so refrigeration and air conditioning subject, I think. Have you, students of third year or in third year right now? Anyone?
So we
Right
know
now,
about
this
it.
semester we don't have.
Can you please pardon?
Right now, in the present semester, we don't have it.
Okay, I'll tell you. So basically, in aircrafts, they don't use any coolant or refrigerant. Okay, they use air as a refrigerant to cool the aircrafts. Okay, so there's a lot of compressed air present in the aircraft, as compressed air is also used in turbines. Okay, or in the combustor of the turbines that are used on the aircraft. So there's abundance of pressure of, you can say, pressurized air present in the aircraft. So what that person did on the in that project is that he proposed to use that bleed air to be shot on the, or you to be to be injected, or sorry, or to be ejected on the aircrafts, so that that pressurized air should clear the runway, should clear the water on the runway, so that there's no incidence of overrunning the aircraft. So this was a very good topic. I thought I should do it, but I didn't get the time to do so. But you should do it. You should just go through what he did. If you want, I'll just send you the uh, paper on that. But it's a very good topic. So, like these, there are many topics present. Okay, this was a basic of CFD one. Okay, okay. So this is the most important. This is one of the most common topic used right now. So basically, you can also design a drone. Okay, so making a drone is not very expensive right now. You can get the components very cheaply. Okay, so there are a lot of research papers present in the, you can say, on the net, where they are made very sorry, they have made many drones on various requirements that they have, mission requirements that they have. Okay, so if thank you for my presentation. If you feel, you are feel free to mail me or connect with me through LinkedIn. Here's my mail and website present. Okay. So if you have any questions, there was a lady want to ask problems, so I couldn't to ask.
Okay,
Yeah,
sir.
yeah, sure, please.
What is the industry demanding right now from the bachelors? Are they more into the analysis part, or are they more into the CFD solver in coding the solvers, or are they just looking for this simulation?
So, very good question that Rajat asked. So, basically, industry is looking right now for bachelors who are uh, have a good knowledge of CFD for analytics only. They are not looking for solvers right now because they think that they are not that they don't have that much knowledge to write solvers. If you have the knowledge, it's very good. But right now, the industry is looking for persons for a candidate from a bachelor's degree who can get you good results that or accurate results according to the according to calculation that they have only in the on the basis of simulation parts. They are not looking for people who can right now code because they are done by more experienced people that are present in that industry. Okay. uh, do you get the answer what I wanted, Rajat?
Yeah, yeah, Aditya, thanks.
Oh, you're welcome.
Aditya,
Yes, sir.
uh, myself, hope you remember me, Dr. Singh.
Yes, sir. Sure, sir. Sure, sir. I remember you.
Yeah, actually, we are in the process of revising our syllabus,
Okay,
mechanical.
sir.
So, in that concern, I wanted to know, uh, as far as you know, I have taught, I am teaching here machine design, strength of material, mechanics, and all these design-related subjects.
Yes, sir.
So, how can you suggest some uh, areas that we need to focus so that our students, those who are now and those who will be getting placed, uh,
Okay.
it can be helpful to them. How in which direction should we orient our syllabus so that that will be helpful for them to get placed in industries, designing industries, and all these kind of industries. So can you
Okay,
suggest?
sir. Okay, sir. Sure, sir. Sure. So basically, industry wants someone who has a good knowledge or practical knowledge. Our college is very good in giving a theoretical knowledge, but if we give them some practical knowledge about the softwares, basically in our in when sir you taught me, you gave us a lot of practical knowledge about designing gears and other stuff. That was very good. It was very helpful for me to design mechanisms when I entered the industry. So like that, if we can get subjects like CFD back, it was in my curriculum, but no one took it, so it was removed. So if we can give a practical knowledge to how to use ANSYS Fluent for a basic knowledge, so it can be very good. From that, students can give a lot of projects about doing CFD. Yes, sir.
That means we need to add one or two modules regarding analysis part,
Yes,
simulation
sir.
part.
Yes, sir. Simulation part. If simulation right now is used in every industry, they use simulation in everywhere to cut down the costing of testing and so on. So they are hiring engineers, thermal engineers, application engineers, analysts, simulation analysts. They are hiring a lot of people in this you can say path. So if we can introduce something like this in our curriculum, it can be very helpful.
Thank you for your very good suggestion and
Yes, sir.
good to hear it from you from after a long time. And very
Okay,
best of luck for future endeavor.
okay. Thank you, thank you, Simon. Thank you very much, sir.
Okay, best of
So right now I've got a question on my chat box. It says that sir, it is necessary for a BTech student to learn Python or Java or any programming language. So Varun, it is very useful to have such knowledge of Python and Java because it is used for very coding purposes. You can also use this for coding. Like Rajat said, it is used for coding solvers in CFD and FEA. So if you have a knowledge of Java and Python, you get an advantage over other students. So it is very good to have this knowledge. Uh, anyone else you want to ask something?
Aditya, I would like to add on that software part,
Yes,
the question
sure.
one has asked. Uh, these days, it's very important to learn software
Yeah, sure, sure. Yes.
because uh, like you said, not only in CFD also, but if you are into many other things which involve the operational part also, having a good knowledge of MATLAB or either Python is a very great thing, because
Yes.
mechanical, there are hardly any chances that we are using Java. Currently, I'm not knowing of any, but yeah, MATLAB and Python are very important these days, because even if you want to go into the production sector also, MATLAB can do wonders for your job. It can make your job very easy.
Yeah, that's a very good point you made, Rajat. Thank you very so much for your input. Anyone else would like to ask something regarding my presentation, or any other question regarding aerospace industry or drones, or any other question you want to ask? Feel free to ask. There's no you can say no one holding you back. You can ask anything you want.
So,
Yes.
can you tell about making a drone or manufacturing it or calibrating it? Something about
Okay, okay. So I'll just give you a small insight about how we design a drone. So basically, what we get as an engineer, what you get as inputs. So basically, the customer that wants to buy a drone give you some requirements that he have. For example, he will give you range, that he wants to a drone which flies to a certain range, and he wants to get your purpose. So on base of that, we select the frame. So in my presentation, I have given you various type of frames that I have. So on that, we decide what frame type should we use. Okay. Then we go on using some calculations that we have made. Basically, what I use, I our company has provided us a Excel sheet on which we have done our calculation and equation parts, and on from that we get some numbers. Okay, like we get the aspect ratio of the wing. Suppose I'm making a fixed wing drone. Okay, so we get some you can say uh, you can get the semi length of the semi length of the wing. Okay, or the tip chord. Tip chord is basically where the drone is attached, where the wing is attached to the body. Okay, so we get those numbers. Then we select an airfoil. Okay, so airfoil is basically a curve or a pattern that is used to generate lift. Okay, so on that purpose we select a you can say a airfoil. So basically in drone industry we use NAC airfoils. Okay, NAC stand for NASA, National Aerospace, again, like something like that. I just forgot the full form. Okay, so we use that those type of airfoils on that. Some This is how we start. So we design a prototype. Okay, then we design it, when we manufacture it once, then we do tests on it. If there's any issues, we reiterate it and do it again. So this is how it goes. So I got another question in my chat box that says, sir, what are the basic skills required in the current industry? Yeah, Rajat, you're right. National Advisory Committee of Aeronautics. Yeah, that is correct. So, Varun, basically, right now, the skills that are required from the software basis, that you should have a good knowledge of a CAE and CAD knowledge. Uh, from my side, if you know how to use sheet metal and other sheet metal designing and normal solid designing, you are able to you will be easily able to design a drone by yourself. Okay, there's not much you can say things required to do so. Okay, if you also have a good theory of you can fluid mechanics, it will also help you to design you can say to compute the airflow over the wings and other components. Okay, so these are the basic knowledge should you have. You also should have knowledge of material science, because material science is used a lot, because the drone should be as light as possible. reduce you can to reduce the thrust that is given, so that your drone should go as far as possible. Okay, so you should have a good knowledge of material science as well. Okay, so there's my answer for you, Varun. Any
Thank
other
you so
question?
much.
Any other question you want to ask?
Yeah, Aditya, regarding the material science part, uh,
Yeah.
does your industry outsource the this particular section like the manufacturing and the material design, all these things, or do you
Uh,
do it in the house itself?
So basically, we outsource the material. Basically, we use in our industry is carbon fiber. Carbon fiber is very light and strong, so we use carbon fiber sheets to make our drones. Basically, we toll drones for that, and we use sometimes for testing. We use MDF for testing purposes.
Okay, okay, thanks.
Thank you. Any other question you want to ask? So it seems like you don't have any questions to ask. So anyone, anyone, you? Hello, Saksham.
Yes, sir.
So seems like it's like everyone that no one has or no one has any questions to ask. So should we? No, I've got one question right now. Okay. So what is your work as an aerospace engineer in of an aerospace engineer in your industry? In our industry. So basically, Ayush, an aerospace engineer what does the designing part. Aerospace engineer does the numerical part in the industry. He designs the components. He designs the mechanic wings, ailerons, and the you can say the tail. So the main job of the aerospace engineer is for of designing part, the numerical part, R&D part. Okay, so I hope you got your answer.
Yes, sir. Thank you, sir.
Oh, you're welcome. Anyone else if you want to ask any questions? Yeah,
Hello.
yeah.
Uh, Sir, actually, due to this current pandemic situation, is there any effect on present aerospace industries?
Yeah, that's a very good question right now. So basically, aerospace industry, they are making drones for thermal scanning right now. They are using drones for thermal scanning the areas. Okay, and they are also doing a lot of drones right now. They are making a lot of drones for you can say that incident happened near Kashmir right now and near Ladakh right now. Between China and India, so uh, they are using a lot of drones for surveillance right now. So this time drone industry is growing very fast. They are using drones for many purposes. Right now, I read a news that the UP government has asked for 1,000 drones for you can say checking for inspection of the crops. Okay, the crops they are on the field. So using these drones right now to inspect that there's no you can say spray pesticides, fertilizers on those drones. So yes, you can say in this pandemic situation, the drone industry has flourished a lot. Okay, so that's my answer for you.
Thank you, sir.
So I got another question from Varun. He asked that which companies after should try for what a BTech in mechanical engineer should try after the for off-campus placement. So basically, there are many companies in Noida. Okay, I can tell you two, three companies that are in my mind. One is Garun Drones. Okay, it is situated in I think sector 62 in Noida. It's a very good company. It has a lot of it has given a lot of projects to, you can say, military about for the tactical drones for surveillances. And okay, and other company I know is Ayan Drones, which is of Pune. Okay, they have made a drone which is solar powered and can go up to a height of 65,000 feet. Okay, so was a very good drone that we saw. And there are many other companies in Noida. I think there are two, three more companies in Noida, so you can try off campuses. You can contact me. I can send you the list of those companies. You can try. Okay, Arun. Any other question you want to ask?
So when we talk about drones, can you tell about how to control the thrust?
Uh, can I didn't get the meaning of question because how to control the thrust.
So means the wings they are used now. The thrust is used.
Yeah, yeah. So basically, we control thrust. Okay. So Uh, so basically, thrust is used for generating lift. Okay, so thrust is, you can say, the you can generate it by the propellers and the motors. So thrust generally depends on the power of the motor that you are using. Okay, some if you are using ramp engines or those engines, so that turbo engines, though for those you use fuel. But if you are making an electrical drone using battery, so for that we use motors and propellers. So basically thrust is generated by those things. Okay, so thrust has a lot of impact on generating lift. Okay, if you have high thrust, that means you need a lot of power. That means your drone is very heavy. And if the thrust is low, the thrust required is low, that means the drone is very light. Okay, so that uh, I think is what you want to ask, Saksham, or is there anything else you want to ask? I think.
No, sir. This so how to maintain the normal that it don't goes very high and not go very less the weight.
Okay, so that is, you can say, I don't have that much experience because I'm not flying a drone right now. Okay, I tried to fly a drone, but eventually it crashed. So I have a very bad experience in flying a drone. So basically, what we do is what generally we do that we use microcomputers. Okay, so we use microcomputers to control those drones. We just set a flight path, like use GPS for that. We set up flight path from, like, from this point to that point. We have to fly a drone. We set the cruise speed and the altitude. So the drone the microcomputer compute itself and controls that thrust accordingly. Okay, so there's not much manually to do.
Okay, sir.
Okay, thank you.
Thank you,
Any
sir.
other questions? Any other question you want to ask?
I guess, sir, there is no more questions left.
Okay, so
Thank you.
thank you
Thank
very
you so
much.
much, sir, for your precious time and knowledge that you have shared with us.
It's my honor to do so. I am very grateful that you all came and listened to me so patiently. I am very honored. Thank you very much. So I just now stopped my presentation, my screen.